Today we test the OmniaDrop Extruder from DropEffect. So this video starts with a bit of a story. A couple of months ago I got really into testing flexible filament. I wanted to get a bunch of different ones with different hardness levels and test how they reacted to different printer setups and just see how it went. In fact, I did a whole video on it. You can check it out up in the corner. But as a baseline, I used my Prusa Mark III. It does have dual drive gears on the extruder, so it should be able to do flexible pretty well, but it does have a little bit longer filament path than other extruders do. And there's a couple reasons why I started this whole thing. One, the release of the E3D Humera. It should be able to do flexibles pretty well, just given its design. And this extruder that we're talking about today, the OmniaDrop from DropEffect. The OmniaDrop has a really short filament path, and it uses a pancake stepper to drive planetary gears to turn two extruder gears to feed the hot end. It also has a really unique hot end setup with a circular heater. And in theory, that heater design should be able to transfer heat a lot more consistently around the nozzle and the melt zone than the regular square block heater setup. The OmniaDrop does come in a couple of different configurations, including a style that will mount right on your Prusa Mark III, and that's the configuration we're going to be using today to install on log. It'll be just a little bit different, but between the two models, it should be pretty much the same assembly process. The OmniaDrop has a 5:1 gear ratio, an extremely short filament path, and dual drive gears, so it should be able to print even the most flexible filament, which we're going to test today. It will also print all the other filaments. It does have part cooling, of course, but it's also compatible with E3D nozzles. So no matter what filament you want to print, you can probably find a nozzle that'll fit it. It's a pretty nice setup so far from what I've seen. It has a pancake stepper motor, and with that higher gear ratio, you can keep the carriage as light as possible. And one of the greatest things about it is that all the printed parts for the extruder are available on their website. So if you break something or you'd like to try to build one, they're available for download. You can just print them out. So today we're going to walk through all the steps of getting this thing put together, installed on your printer, and test some extremely flexible filament. So let's not waste any more time and get right into it. And here's what you're going to get inside the kit. It does have a lot of 3D printed parts. The quality is pretty nice. You have the extruder body, the idler arm, some wire management pieces, a fan duct, the idler knob, the planetary hub, and the planetary gears. You have a very unique heater cartridge and thermistor here. It's round. The barrel actually screws into it. I'm pretty excited to see how that's going to work. We have two-part cooling fans, a heat sink, and a pancake stepper motor. They do include some thermal grease, all of the hardware you need to assemble it, including the bearings, springs, square nuts, things like that. Your filament drive gears, one of them is actually threaded. That's a pretty cool design. I like to see that. A silicone sock for that round heater, your barrel, and what appears to be an E3D nozzle. So the first thing we'll do is we'll take our planetary hub and we're going to put these flanged bearings in all three of the holes on both sides. 3 on that side, 3 more on this side. I'm just going to hold the bearings in with my fingers, but we're going to take our 5mm hex bolt and we're going to thread it through this side. There's a spot on one side for the hex head. Then we'll put our 5mm fender washer on top of that. In the kit, you're going to have 2 of these nuts that have a flange on the outside with flat spots. That's the next thing that you're going to put on. You want the flange side to go down next to the washer. You can just make these finger tight. You don't have to get carried away. Next, we'll take our 3 M3 by 14mm screws, our spur gears, 3 M3 washers, and 3 nylock nuts. And the screws will go down through the bearings from this side. Your nylock nuts will set inside your spur gears. Then we'll flip it over. We'll put our washers on, all 3 of them, as a spacer. And then your spur gears, all 3 of them, will thread down on all 3 of these screws. There's one on. You don't have to get crazy with tightening these. I tighten them down until I can't hold the gear anymore with my fingers, and then I back it out about 1/4 to 1/2 a turn. That seems to be pretty good. They do have to be able to spin relatively easily. There's all 3 of them on. Remember, we want these to turn freely. Again, about 1/4 turn after you tighten them up, back it out. Should be good. Next up, we'll slide one of our bearings on. Then we're going to take our threaded filament gear with the gear teeth for the other gear down and thread it on the bolt. And we're just going to snug it up right next to that bearing. The bearing will still turn. And then we'll put the smaller M5 washer on top of that. Then we're going to take our housing. Sorry about the white, it's kind of blown out there in that camera. We're going to take our other internal M8 bearing and press it in right here. And then our whole planetary housing will go in through the back, just like so. You can push it in as far as it'll go. Then you want your other nut with the flange on it to go on that to secure the bearing on the other side. Again, these can just be hand tight. At this point, make sure your teeth are lined up with the filament path right there. That's good. And make sure the whole thing turns smoothly. And it's looking good. Definitely take advantage of watching it work on the inside. This is a whole lot of fun just by itself. Now that we're sure that everything's spinning freely and we're lined up, there is an extra grub screw on this gear. Even though that gear is threaded onto that bolt, it's still a good idea to go ahead and tighten these down. I like to wait until the absolute possible last moment to tighten these because I don't like to tighten them any more than I have to. Because these are so shallow, a lot of times you can strip them out if you just use them a couple of times. So the less you have to deal with that, the better. So we'll go ahead and snug that down now. We should be good there. That just gives us a little extra insurance so that gear doesn't move. Next we'll take our advancement knob. This goes on the other side so you can turn the whole mechanism to feed filament through. I might have called it an idler knob before, but that's not true. We're going to take our large square nut and put it in there. This will go on this assembly. Spin it down so it's somewhat tight, so this knob will turn that whole assembly. That's what it's for. And then we have an M5 nylock nut to hold the whole thing in place. After that, it's a good idea just to make sure everything is still turning freely. And we're good. Next up, we're going to take our M4x16 screw. We're going to put it through this hole back here. Then we'll secure that with another one of these large square nuts. Then on that screw, we're going to take our knurled nut, and with the flange of that nut facing the printed part, we're going to screw that on. And then on top of that goes our spring. Then we're going to take our other filament drive gear. We're going to load the bearings in either side. Then we'll take our idler part, and we're going to set our gears in here just like this. Make sure these teeth line up with the teeth on the housing for the other gear. It should go in just like that. And then take one of your M3x25mm screws, and we're going to thread it through here to hold that gear on. Make sure it spins nice and freely. Then we can set it on the housing. And your other M3x25mm screw will go in the side hole right here through this housing to hold it on. There is a little divot on the top of this part that sets on top of that spring. And with that door on, now you can use this knurled knob back here to adjust the spring tension, how much it's going to grip that filament. And it's probably not a bad idea to stick some filament in there just to make sure that it's going to grip it, that you can pull it through, and everything's lined up. And it looks to be working pretty well. Now we're going to mount the pancake stepper to the side of the body. This gear goes in the middle of all three of these planetary gears. This is the back of my body. So I'm going to put the wires going to the back of the machine so it's easier for me to route them. So I'm just going to press it in just like this. You might actually want to turn the gears just a bit to get it to line up so it'll sync with all three. It should go together just like that, no gaps. And from the other side, we're going to take our longest M3 screw with our last remaining M3 fender washer. We're going to come from this side and screw it in to the mounting holes on that pancake stepper. Then we'll take our heater, and you're going to have these two flat spots on one side. On the opposite side, that's where your nozzle goes in. Screw the nozzle all the way down, and then back it out one turn. Then we're going to take our heat brake, and on the cold side of the brake, the longer side, we're going to put some of this thermal grease that they gave us. Be careful, this probably isn't the kind of stuff that you want on your hands. And when that grease is on, we can screw it into our heatsink/heat block from the bottom. We want that barrel flush with the top of the heat brake, and then we need to clean off any excess thermal paste. You don't want any of that in your filament path. And then this side of the heater will screw onto your brake. And there we've got it installed. Remember, we have our nozzle backed out one turn, but that brake should go right up against that nozzle, and then when we heat it up, we can go ahead and torque it. But just as tight as you can get it with your fingers is good for now. And then this whole assembly will slide under just like this. And then you can take a couple more of your really long M3 screws, run those through, fasten them to the pancake motor. This will be snug enough up against this printed part so that it won't allow that brake to back out. I just realized that there's one of these screws that's just a little bit longer than the other one. Be on the lookout for that. I thought these were all the same length. The ones that hold your heatsink and your nozzle on are the M3x45. There's 3 of those. Our heatsink and nozzle assembly is complete. I just backed out that heater a bit to get it snug up against the plastic part. Now we're going to assemble the part fan. I actually show a different part fan duct at the beginning of the video because I didn't realize that I didn't have the newest version. So this is the Prusa version. There are 2 different versions of this setup. You have a hot end fan for the heatsink up here. You have a part fan over here. The part fan will slide in just like this. And then you have 2 M2 screws that are going to hold it on from the back. They are very tiny. Don't sneeze, you will lose them. You have a screw and a washer. One will go in right here, and then the other will go in over on this side. Part fan's on, then this whole thing's going to go on the assembly. It sets on the heatsink just like this. Then you have 2 M3x8mm screws that go in these holes here to hold it on. Those 2 are in. Now the fan for the hot end will go in there. It sets in just like this. And then again we have 2 M2x6mm screws and washers to hold it down here in the corners. And now that that front fan's on, we're pretty much done. So that's the whole assembly. This is the Prusa version again. So it should just mount on those X bearings on the carriage like I already have here on log. 2 on the top, 1 on the bottom. It already has the belt holder with the zip tie spots, so it should be easy to install. They do give us this management piece for some of the wires so you can zip tie them down like on the Prusa printers, but I think I'll wait to install that until we get it on the machine. There is a really long M3 screw to hold that on there. So let's get the printer taken apart and get this thing put on. So this is a stock Mark III's assembly. They're pretty easy to take apart, but we are going to take this all the way down to the bearings, remove the belts and everything. I don't think it's really valuable for me to show you that whole process. I'm just going to take it off and then we can work on putting the new extruder on. So I've completely removed that extruder. All we have left are the bearings and the belt is hanging. I don't think we'll have to make any modifications to the belt, but we'll find out in a second. And before I start the install, the hot end fan and the part fan are the same fan and they have the same wires. So I want to make sure that I mark one of them so I know which one goes where. I'm just going to mark the part fan plug right here. And this whole housing should just line up like the older style Prusa. You've got your bottom bearing down here and the 2 upper bearings up here. And then you have spots for zip ties to hold it on. So we'll put some zip ties on there. Then we can go ahead and put the belt on. I will have to loosen this motor up. On the Mark II style design, that's how that belt is tensioned. So I'll just loosen those screws. And we'll feed the belt into the teeth on the plastic part on both sides. The belt went in just fine. We should be able to tension that. But after looking at that, it looks like it's best if we run all these wires underneath. So I'm just going to pull these back through. So we're just going to run them under like that. Now I'll go ahead and put these screws back into this motor so I can tension that belt. Tension looks good. I didn't need to make any adjustments to the belt length, but there is a little gap in the middle in case yours is a little longer, just so you don't have to cut it, but mine seems to fit pretty well. Now there is one more part that I did not show you at the beginning of this, and that is the Pendaprobe mount. You should get this with the Prusa edition, but it attaches over here, so let's put that on now and get that wire ran. So they give you 2 M3x14mm screws and the square nuts for this mount. One to hold the probe on like this, you just slide the nut in there. And then this whole thing goes back here on the extruder body. It screws down to this hole right here. There's threads in the heatsink to hold it on. It just sets on here like this, and then you use your M3x14 to attach it. Our Penda mount is on right there. We'll go ahead and put our probe in. Now on log, I use one of these more affordable AliExpress M8 sensors. They're about $3, but they're a lot longer than the actual Penda probe right here. This is the Penda 1 probe. So if you have the longer sensor, you might have to rework the part because it's going to be just a little bit too long to fit in here. So either switch to one of these Penda 1 probes, you can get them from Printed Solid, or we'll have to make something up. For now, I'm just going to go with the actual Penda probe. So we'll just slide that into the mount. We'll snug it up for now. It will take some adjustment. And the wire actually runs over both belts, but under that top rod, so right through here, there's a little guide hole you can see for it. The probe is actually quite a tight fit in between the probe and this knob, so make sure you have it low enough That will probably be the correct setting anyway. I'm just noting that it can really easily hit this knob. So let's make sure it's low enough. Now that's all for the wiring. We can do some wire management. They do give you this plastic piece. It's kind of like the one that comes on the Prusa. It sets right here. Then you can use zip ties, but they do give you a long M3 screw to attach it, and you have to slide a square nut up into here to hold it. So this one is an M3 by 50 millimeter screw. We'll put our square nut in the bottom of the body, and we'll attach it. It goes right side up like that. We'll screw that on, and then that gives us a hole where we can put our nylon. That's the plastic that they use for that wire loom to keep it sturdy. Now, after doing some test runs and some dry fitting on this, I've come to a couple of conclusions. This mount was really designed for the Mark III. And I say that because there's really not enough clearance to trigger an end-stop switch on your X, because Mark III has sensorless homing. Good for us that log does have 2209s, so we can enable sensorless homing to utilize that, but that's something you're going to want to know up front. Also, when I put my pancake stepper on, I routed the wires out the back. Even if we use sensorless homing, that's going to tend to pinch those motor wires, so I'm going to roll the stepper so the wires come out the bottom. Fortunately, even when the whole thing is together, that's a pretty easy change to make, because all three of the screws on the side of the extruder that hold the stepper on, this one and these two down here in the heatsink, are accessible while the whole thing's together. So I'll leave you a note in the other part of the video, but I am going to roll that pancake stepper so the wires go down, and we'll switch over to sensorless homing to make this whole thing work. Just be aware of that if you're going to use one of these extruders. It does change up the print volume size just a bit, but we can deal with all that in the firmware. Now that I've got the motor wires ran underneath, I'm going to situate all of this so that the wires run under this plastic part so it doesn't interfere with our sensorless homing. If it has to run into anything, it can run into this plastic part, but it shouldn't. And I'm going to put all three of my zip ties so that the head is on this side when we tighten them up, so it doesn't interfere with that side of the travel. The pin to probe wire does come from up above, but I'm going to try to situate it so that I can zip tie it underneath down here. And before you get all three of your zip ties on, make 100% sure that the wires underneath are higher than the nozzle. There's not a whole lot of clearance in between this and the nozzle tip. Just make sure they're not going to hit anywhere on the bed surface. We should be good just like this. This should be good. I'm going to go ahead and put some spiral wrap on it just to make it a little cleaner. With the wires in pretty good shape, now we're ready to cable up to the board. Log is currently running an SKR 1.3 board. I've had this one in here for a while. I actually find it just a little bit more versatile when I'm trying out different drivers than some of the other versions of board. I have removed some of the wires so it's easier for you to see. I am going to remove the X end stop because I'm just going to run sensorless homing on X for this extruder. That should make things easier. If you want to use sensorless homing, you do have to cover up your diag pins. I'm just going to cover up the ones from X right there. We'll plug in our new thermistor over here. Our Z probe on Z min. Our extruder motor. We might have to flip that direction, but we can do that in the firmware since I have to reload it anyway. For the hot end fan for now, I'm just going to put it on a constant 12 volt. I do have my current hot end fan hooked up to HE1 so I can control it, but just for this test, we'll just keep it always on. It's a pretty small fan. We'll hook up the hot end heater. We've got that right back here. And we'll hook up our part fan. That's in fan 0 up front. The wiring's complete, but a little messy. I'll go ahead and finish up everything else that I unplugged just for the video, and we'll get to the configuration. In VS Code, this is my working SKR 1.3 configuration for log. We're just going to update that. So first thing we're going to have to change is the micro stepping. You could do this with a G-code command, but since we're going to edit the firmware anyway, I'll just do it right here. The original Prusa Mark III does have 32 times micro stepping on the extruder, so that value will be much higher. If you're using something like my machine, I have 16 times. So the value for this extruder will be 480. The thermistor settings are up here up above, but the thermistor used on this extruder is the same one that Prusa uses. We use an E3D style, that's number 5 for the extruder. We're just going to leave that default. We will want to do a PID tune after we get everything set up. I'm going to turn my filament runout sensor off because I have removed it. If you have a Prusa printer, you're going to have to turn those off in the menu. Filament runout and fans check. Remember that. And as far as bed leveling goes, the adjustment for that probe, I'm going to have to play around with mine for a bit. On an original Prusa machine, you should be able to just handle that in the G-code with a couple of commands. They do give you that information on the extruder website, but I, again, hit specific points, so I'm going to have to adjust that by eye, I'm afraid. But after this first compile, I'll run a G29 and see where it's going to land and just see what happens. I need to adjust some things in configuration_adv.h. I'm going to take my X home bump down to 0 because I'm going to use sensorless homing for X only. I will more than likely have to adjust these numbers right here. That's the probe edge. It's probably going to change a little bit because the extruder configuration has changed, but I'll come back to that. And down here in the trinamic configuration, we do have this set up to run 2209s. I'm going to change my E motor current down to about 500 because we are running a much smaller motor. I'm going to enable sensorless homing. You shouldn't have to comment out anything because you're not using it. The board will know what to do because we have that jumper. And or if you have another board, you clip the pins. I'm going to go ahead and set my stall sensitivity to about 65. If I remember correctly, that's what it was when I did this configuration earlier. And we should be good for the first upload. So I'm going to cable up USB, I want to power the printer on, and I'll head over to Marlin Auto Build just because it's easier than going through the menus. It already knows what board you have based on your configuration files, and I'll hit upload. The upload is complete. Now we need to figure out a few things on the printer. First thing I'm going to do is get my pin to probe in the right spot. So I'll go ahead and power down, and I'm just going to move the X carriage down to the bed and set the nozzle on the bed. After you do this on an actual Prusa machine, you probably want to run that Z calibration. The nozzle is on the bed. Just going to grab a zip strip, run it underneath my pin to probe. That gives me about 1 millimeter of offset, and then I'm just going to tighten that probe up. That should give us a good starting point. Let's power up and run some tests. We'll connect up with Pronterface. Let's make sure our EEPROM's overwritten with all the new configuration. M502, M500. We will take a look, M503. We have our stall guard thresholds right here. Let's make sure we're moving in the right direction. Nothing should have changed, but you never know. Let's up just a little bit so we don't scratch the build surface. We'll head to the right, head to the front. Should be good. Let's see if we can home X without crashing. And it did home, so we're good there. Let's home Y. The end stop is still being honored. That's a good sign. Let's home Z and just see where it's going to put that probe. This is where our adjustments are going to come in. So we're pretty close. We're about 1 millimeter off to the right of where we should have been because of the added space for this pancake motor on this design. Sensorless homing is enabled. So we probably just need to move it over just a bit, and that should clear things up. So I use safe homing to get to that specific probe point. I'm at a 31X right now. I'm just going to take that down to 30. And then in configuration_adv.h, I'm going to take my left edge down to 30 as well. So really we only had to make a minimal change. And again, that's probably going to be different on a Mark III versus the Mark II design. Log is completely different than everything else, so you never know what's going to change. But we should be good. Let's go ahead and re-upload. New upload's complete. We'll go ahead and power cycle. Back to Pronterface. We'll go ahead and reload. We shouldn't need to, but it's a good habit to get into. M502, M500. And let's just go ahead and home all. I'm pretty confident it's going to work. And that location looks a lot better to me. So I'm going to go ahead and G29, do an auto level. And on this side, I need to come back just a little bit that way. Maybe 3 millimeters. So I'll change that up. So we'll make that right edge. Let's just make that an 18. And we'll go again. And after that, I'm much happier with the probe locations. Now, next thing I'm going to do is I'm going to raise Z up so I can get to the nozzle. And then I'm going to heat up and do a torque on that nozzle hot. That just ensures it's going to be plenty tight and it's not going to come out. We'll heat up to about 260. After we're up to temp, I'm going to grab the hot end with a set of pliers. It's actually a little easier than the square blocks. You can just use those 2 flat spots at the top. I'm going to use my Slice Engineering torque wrench with a 7mm socket and give it a torque. That should ensure it's not going anywhere. This is also a great time to make sure the extruder is turning in the right direction. There is a break-in sequence that we're going to do next, but we should be able to turn it just enough to confirm that it is spinning correctly. So I'm just going to extrude 5 millimeters. And it's turning counterclockwise, so we should be good. Remember, you can either alter that in the firmware if it's turning the wrong direction, or in this case, we have a DuPont connector, so you can just flip the cable. So we're good here. I'm going to go ahead and turn the heater off and cool down. If you head over to the DropEffect website, they have this Planet Gear run-in script. It's just a G code that runs for a couple hours to make sure that Planet Gear is nice and free before you start using it. It tells you how to adjust your microstepping. We've already done that. You don't want any filament loaded, and we do have to adjust the G-code a bit before we use it. So we're going to go ahead and download it. And we'll just extract that zip and take a look. Here's our G-code. Let's just open that up in Notepad++. And basically it's just commands over and over to work in those planetary gears. This is going to send a G92 command of 480. We already set that in our firmware. If you have a preset, you're going to need to update that. They do mention that out on their site. But we should be good. It's going to save EEPROM. We're okay with that. And then it's going to start this whole sequence. You do notice this M302 command. That disables cold extrusion, so it allows the extruder to spin without the hot end being heated up. Some firmwares don't support this, so you might have to heat up your hot end before you run this script, but Marlin accepts that, so no big deal. So we'll just run this G-code. Let's just run it from Pronterface. Let's load the file, and we'll hit print. So the printer's going to run that G-code for a couple of hours just to make sure the gears are good and broke in. If you hear skipping or something like that, you might have to adjust your voltage or help it a little bit with the knob just to get all those gears nice and broke in. But we'll just let it run and we'll come back when it's done. So our run-in test after 2 hours, it's done. No problems that I could see, no strange noises, so I think we're okay to continue. I do want to do a PID auto-tune before we try a print, so let's do that now. So I'm going to run an M303 E0 for extruder 0. I'm going to let it cycle 10 times with a C10, and I'm going to set the temperature at 210 C. So we'll go ahead and let that run. And when it's complete, it's going to spit out some values that you can enter into your firmware. So we can copy these, and it's a good idea to go ahead and do this just to make sure that configuration.h is consistent. So we'll head back to VS Code. And if you search for PID, you've got PID settings for your bed and for your hot end. I'm not currently using it on the bed, but you can just add your settings right in here. We'll just comment out the defaults, and we'll paste in those values that Pronterface spit out. So next time you upload, this will be up to date. If you do an M503, you can see that our M301 settings, that's our PID settings for our hot end. They're currently still set to default, so we don't have to re-upload. We can just go ahead and run that M301 command now and save it in EEPROM. We'll do M301. P, and then the first value that got spit out, 12.73, and then I, the second value, 0.90, and then D, 45.22. We'll just hit enter, and we'll do an M500 to save it in EEPROM. Even after you flash, if you update your firmware and reflash, you're going to need to update EEPROM with an M502, M500 again, to pull in those new values. So we should be good with our PID settings. Now these extruders are designed to work with flexible, but they should work with any other filament as well. So let's just start out easy, and we'll try some PLA. So let's go ahead and preheat. And while we're preheating, it's also important to note if you have the silicone sock, I think these are relatively new, but if you have one, you can go ahead and put it on. You might want to consider putting this on before you do your PID auto-tune. It might make a bit of difference, but maybe not a ton. So go ahead and use it if you have one. I'm just going to hold the filament in the top of the idler arm right here. You could just use this knob to go ahead and load it. That's probably the easiest. You can probably do it from the menu as well. There are load options if you have the advanced pause feature enabled. But this is pretty easy. We've already got some filament coming out. So let's just start a print and make sure everything's working correctly. We will have to set our baby stepping for our Z offset. I already have all that set up in the firmware. That should be no big deal. We'll print from media, and we'll just start a print. And I'll just adjust baby stepping on the fly. I can double click the encoder. I currently have a Z offset of 0.2, maybe just a little bit more squish than that. I'm going to roll it up to negative 0.3. That looks pretty good to me. So let's go ahead and let it print, and we'll see how we do. This should confirm if we have any heat creep or the extruder's missing. We can kind of adjust the idler if we need to, but this should be a good test. We'll see how it goes. So the first attempt, after the first couple of layers, the benchy did start to separate. I was missing some extrusion, so I decided to turn the motor current up a bit. We set it at 500, so I went up to 650. The motor is just a touch warm, but nothing really outrageous. We're looking a lot better on this attempt, so we'll let it run and see how we do. Our PLA print is finished. Let's check it out. I have to say, with zero tuning, that print looks pretty good. The extrusion is pretty consistent. We might be able to adjust it a little bit and get it even better. But honestly, I really like the way that looks. So the PLA print looks pretty good, but this extruder really wasn't designed for just any old filament. It was designed to print flexible. And why would we want to mess around with this test? We want to go with the most flexible of all. This is X60. I'm not even sure if they still make it, but it has a 60A shore hardness. So it's extremely flexible filament. My buddy Mike over at Never Let the Machines Win happened to find this spool and he sent it right over for testing. So let's get it loaded up and see if this new extruder can print it. I want to put a little glue stick down so it doesn't stick too good to my PEI. And I'll back my PLA out. And we'll try to feed the X60 in. It does grip it. And it looks like we made it to the nozzle. So let's give it a try. Now with the X60 we're going to be running a little slower, but not that much to start out. So if this fails, I won't be too surprised. We are running 50 millimeters a second on the perimeters and 60 on the infill. Auto cooling is not enabled. Retraction is set extremely low and at a reduced speed of 25 millimeters a second. So let's see what happens. And the X60 Benchy is done. We finished it in 2 hours and 13 minutes and 59 seconds. That's pretty respectable. Those of you that have ever printed with X60 know just how difficult it can be. It's pretty much like printing with frosting. The Benchy is not the best model for flexible filament, but it's kind of my thing. And the fact that we could even complete it with X60 is very impressive. And to give you a little closer look, you can see the overhangs aren't all that great, but again, this is really flexible filament. It was just kind of piling it up in some spots because it actually moves the model before it lays the print down the next layer. So it's not going to look so awesome. But this stuff might as well be made out of latex. I mean, it is ridiculous flexible. So there we have it, and I'm just happy that the X60 Benchy completed it all. I've never completed a model like this with this flexible of filament, so I'm pretty impressed with this extruder altogether. And if you're looking for an extruder that will do extremely flexible filament, definitely check this one out. I'll leave all the information in the description below. Thanks to Max for sending this over so I can try it out. I also think this would be a great candidate for the tool changer. We could make it into a tool changing head, so if you had some flexible material, you could use it for that, plus you can use it for all your other filaments, and it would always be available. So maybe stay tuned for some of that content as well. Hopefully you found this helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below, and as always, thanks for watching.